Undoubtedly, our perpetual concern revolves around the future, what lies ahead tomorrow, the day after, or even in the coming year. It feels like we were simply enjoying ourselves in early 2020, and suddenly, the world came to a halt. Despite all this, let's consider the broader perspective. Isn't that why you're here? Have you ever pondered what might transpire in 4 billion years? While it may seem like an extensive stretch, in the cosmic scale, it's merely about a third of our existence. Throughout this presentation, we'll explore significant astronomical occurrences that could potentially unfold over the span of 4 billion years. Before delving into the future, let's take a closer look at the past. The most recent findings from NASA's WMAP satellite suggest the universe to be 13.75 billion years old, with a margin of error of 0.1 billion years. This underlines the challenge of attempting to peer into the cosmic timeline. If looking into the past is arduous, trying to foresee the future is undoubtedly a daunting endeavor. Additionally, the observable universe spans approximately 93 billion light-years in diameter. This implies that light would need 93 billion years to traverse from one end to the other. I'd venture to say that exploring the entirety of the universe within one lifetime is an impossibility for us, mere living beings. However, astronomers, aided by the Hubble telescope, claim they can predict the future trajectories of stars in the universe, not just for a few years, but for a staggering 10,000 years ahead. How is this accomplished, you ask? The astronomers employed a method utilizing the Hubble telescope to meticulously track the movement of 100,000 stars within the Omega Centauri cluster over a span of 4 years. Omega Centauri itself stands as one of the star clusters within the Milky Way galaxy, situated roughly 15,000 light-years away from Earth. This cluster remains observable in the southern sky, even visible to the naked eye. Interestingly, the ancient astronomer Ptolemy once cataloged this entity as a single star. Centuries later, advancements facilitated by the Hubble telescope revealed that it is, in fact, a densely packed cluster comprising millions of stars, exhibiting collective movement akin to a swarm of bees. Using data collected from 2002 to 2006, astronomers constructed a simulation of these stars' trajectories, serving as a foundational reference for predicting their motion thousands of years into the future. Naturally, uncertainties exist, notably concerning whether this baseline, projected far into the future, adheres to the second law of thermodynamics, which dictates an inevitable increase in entropy over billions of years. The validity of this baseline model in the distant future remains unknown. Therefore, it's prudent to approach the information presented in this video with a level of skepticism. Yet, before we delve into the specific events, allow me to spoil the ultimate outcome of this journey. In 10,000 years, the red supergiant star Antares is anticipated to undergo a supernova explosion triggered by a depletion of hydrogen in its core. This explosion is expected to be so colossal that it will be visible from Earth during daylight. Moving ahead to 15,000 years from now, Earth's axial tilt is projected to reverse. Consequently, the occurrence of summer and winter would be inverted, taking place on the opposite hemispheres of our planet. In 20,000 years, Australia is forecasted to encounter its initial wintry Christmas in an unprecedented span of 20,000 years. Interestingly, the last time Christmas coincided with the wintry season in Australia was an era when Christmas itself was non-existent. However, this shift would also entail the Northern Hemisphere experiencing heightened extreme weather patterns due to a significantly elevated land-to-sea ratio. Moving forward to 20,000 years ahead, Earth is projected to confront a supervolcanic eruption of a magnitude posing a severe threat to life and potentially capable of obliterating entire civilizations. Picture the Krakatoa eruption of the 1800s amplified by 1,000 times. Should humanity manage to endure such an event, it's likely that technological progress would regress to a point reminiscent of an age devoid of significant advancements. Progressing to a span of 100,000 years, the constant stellar movement within the Milky Way galaxy would render many constellations invisible in the sky, with several undergoing complete transformations in their geometrical formations. During this time frame, the hypergiant star Y Canis Majoris is anticipated to detonate into a supernova, dispersing traces of its explosion, including valuable metals like gold and platinum, deep into space. Looking ahead to a period of 500,000 years, the star Wolf-Rayet WR 104, albeit a complex designation, is estimated to undergo a supernova explosion, generating a gamma-ray burst of such immense potency that it could eradicate biological life on Earth. When a star possessing a sufficiently massive core erupts into a supernova, the resulting radiation releases gamma rays, carrying 1,000,000 times more energy than standard light. Approximately 750,000 years from now, astronomers foresee the potential impact of an asteroid roughly 3,000 feet in size upon Earth's surface, creating a crater spanning 250 miles in diameter. This catastrophic event would initiate massive fires, rendering the air near the impact site unbreathable. Nevertheless, there remains a glimmer of hope that humanity might possess the technology required to intercept and eliminate the asteroid before it reaches Earth, assuming humanity persists until that era. I'm sure you're familiar with the renowned Arizona crater, boasting a diameter of 1,200 meters. However, owing to the erosion of Earth's surface, in 1,000,000 years, this crater will likely have entirely smoothed out, rendering it unrecognizable to anyone from the 21st century. Fast-forwarding to 10 million years from now, the moons of Uranus, Cressida, and Desdemona are anticipated to collide due to alterations in their elliptical orbits. In 50 million years, a collision between Mars and its moon, Phobos, is predicted. This impact would cause substantial destruction to the planet and alter Mars' orbital trajectory around the Sun. Looking ahead to 100 million years, Earth faces a potential collision with a 10-kilometer-sized asteroid, akin to the cataclysmic impact 65 million years ago that led to the extinction of the dinosaurs. It's speculated that such asteroid impacts occur approximately every 165 million years. Half a billion years later, a gamma ray burst within 6,500 light-years from Earth would result in catastrophic consequences. The burst's potency would swiftly destroy the ozone layer and halt photosynthesis in plants, ultimately leading to the eradication of life on our planet. In 1.5 billion years, the Sun's luminosity is predicted to surge by approximately 10%, causing the Earth's average temperature to soar beyond 116 degrees Fahrenheit. However, this might not sound excessively hot as it denotes the average global land and ocean surface temperature. For context, in March 2020, Earth's surface averaged at 2 degrees Fahrenheit. Jumping to 3 billion years ahead, there's a 1 in 100,000 chance of Earth being ejected into deep space due to the perpetual expansion of our universe. Additionally, there's a 1 in 1.3 million chance of being ensnared by another star's gravitational pull. In 4 billion years, a momentous event is forecasted, a cosmic collision between the Milky Way galaxy and the Andromeda galaxy. This collision will bring together billions upon billions of stars, birthing new star systems while others fade away. There's a possibility that habitable planets akin to Earth might emerge from this cosmic amalgamation. If Earth withstands this collision, our planet would become part of a grander structure, a galaxy dubbed Milkdromeda. The universe's transformations over the next 4 billion years remain uncertain. Its immense scale harbors countless possibilities, leaving us pondering whether humanity can persist through this expansive timeline. Perhaps advancements in technology will enable us to colonize entire galaxies. Conversely, our current comprehension might be so limited that we're unaware of what the future holds. Ultimately, it's our innate curiosity that defines us as humans, propelling us to explore the unknown and seek answers to the mysteries that lie ahead. If you enjoyed this journey, make sure to subscribe to our channel for more content.